Okay, a little bit about amplitude and period. Well, first off, what is amplitude? Well, amplitude by definition is, if you look at it, it says you have the graph of y equals a sine x and y equals a cosine x. Represents half the distance between the maximum and minimum values of the function, and it's given by basically this. Now think about it. That amplitude is how far from the middle you're going to be. So the number in front of it is the number it's going to be. Now think about this. And it says absolute value, meaning all answers are going to be positive. We'll work an example out here in a second that will explain it a little better. But by definition, basically the amplitude is simply the a value in front of the sine or the cosine. And let's look at what the period is. The period is the time it takes it to repeat. And if you look at the function a sine bx or a cosine bx, the period is this. Think about it. The period normally repeats every 2 pi. Well, it's 2 pi unless acted upon what I call the unbalanced force, and the unbalanced force is b. And so to find the new period, how often it's going to repeat, take 2 pi and divide it by b. Well, Coach Tony, that's great little formulas up there. Absolute value of a and 2 pi divided by b, but what do I really do? Well, here's what you really do. Let's look at these two particular problems. Y equals half cosine x and y equals 3 cosine x. Let's look at the first one. Notice, if I was to graph my regular sine graph, here are my zeros, right? And there are my maximum minimums. What's half of 1? It's right there. Half of negative 1's right there. If I put that together, I just graphed it. Woo! By using the amplitude. Now what about the other one? 3. Think about it. It goes up 3, because 3 times 1 is still 3, and 3 times negative 1 will be negative 3. I've still got to go through the zeros, but now I'm going to start up here. So there's my graph for it, y equals 3 times cosine x. That's what they're talking about there on that vertical shrinking stuff. But let's look at that amplitude only part. What is the amplitude? The amplitude is this. The value in front of the sine or cosine, and amplitude is always positive. Now look at this one here. I have 2 sine x. Guess what the amplitude is? Well, what's the value in front of it? It's just a 2, right? Now look at the next one, number 2. It has a negative 3, but amplitude's always positive. If I put that in absolute value part, the amplitude is just 3. Well, what about 3? It's not a number. Well, yes it is. A fraction is still a what? A number. Well, look at number 4. I got something in the other part, the x divided by 2, but that doesn't matter. Just look at that. What's the number right there? 5. So, and then here we're going to look at this next one. And we have that negative 2, a equals 2 right there. There we go. That would be the part that we're looking at. That would be the amplitude. And what about the period? Well, look at it. Period is 2 pi divided by b. So let's look at it. What's the number in front of the x here? 2. Normal period is 2 pi for sine. So I'm going to take 2 pi and divide it by 2, which will give me pi. Oh, what about the next one? 3 won't go into 2 pi evenly. Well, guess what? The answer is just then 2 pi over 3. Oh, okay. Now what about, but Coach Tony, what is that? Now I got this x divided by 2. Well, that's the same as 2 pi divided by 1/2. Because there's the same as 1/2, right? Well, what do? I got 2 pi divided by 1/2, so how do you do that? Well, I don't know if you can hear that or not, but that was Diana Ross singing upside down. Because you have to multiply by the reciprocal. Turn the reciprocal upside down. So that means I have 2 pi over 1 times 2 over 1. Well, that's just going to be what? 4 pi. So the period there, when it was divided by 2, actually lengthened. Here the period got shorter because you're multiplying, getting there faster. Here we're dividing, so we're getting to the normal period slower. So that's why it's longer, 4 pi. Ooh, what a concept. Look at the next one. Well, it's 2 pi divided by 2/5, and once again I got to turn it upside down. Now this time the 2's will cancel, or you could take 10 pi over 2. But if you get 10 pi over 2, it's going to be wrong because that will reduce to what? 5 pi. What about this next one here? Only thing that matters is right there. What's that b value in there? It's a pi. So now I'm going to take 2 pi divided by pi. Well, wait a minute, the pi's cancel and just 2. I can have a period without a pi in it? You sure can. So you just have to find the period. It's the normal period, which is 2 pi divided by the b.